The next topic we need to cover in our C# fundamentals is that of arrays. We use arrays because sometimes we need to store multiple values of the same type in a single structure. That's a lot of words, but basically all I'm saying is that sometimes we might want to store a list of numbers or a list of strings, like for example the 50 US states. When we create an array, it has the following constraints in C#. First, all of the types of data in the array must be the same type. So if we create an array of integers, we can only store integers in it. Strings can only store strings. We can even create arrays of classes. So if we had like a student class, we could create an array of students that would represent all the students in a classroom. An element is what we call an individual item in an array. So if we had an array of 50 states, Ohio would be one element of that array. An array's dimensions, also known as rank, is the number of indices needed to access an element. And as we get into arrays, you're going to see that if we want to access an individual element, we have to provide a number or coordinate. The number of dimensions determines how many numbers we need to get to that element. The length of the array is the number of elements in all dimensions. That's basically programmer speak for saying how many slots do we have in this storage structure. Once we define an array, the size of the array cannot change. This is specific to C#. Some languages you can infinitely grow an array, but in C#, if I say an array has 5 elements, it can only ever have 5 elements. There's a couple different types of arrays. The first and simplest type is called the single dimensional array. It only has one dimension, so all the values are in a straight line. It's basically a vector. And here's what a single dimensional array looks like. We have 6 elements available. The rank of this array is 1 because it only has one dimension. The length is 6. However, the important thing to note as a beginning programmer is that the first position in the array is index 0. Arrays always start counting up from 0. So the length is 6, but the last position in the array is 6 minus 1, 5, because the array starts counting from 0. This is a common point of confusion for beginning developers. They'll try to loop an array and go from 1 to 6, and then when it gets to position 6, which doesn't exist, you will get a very specific error called an overflow error, or index out of range. A multi-dimensional array has more dimensions, and these arrays can be rectangular, where you have the same number of elements in all directions. This would be like a box, a grid, or a cube. Or you can also have a jagged array, which is basically an array of arrays. First, let's look at a two-dimensional rectangular array. In this case, we still have 6 elements across one dimension, but we also have 3 elements across the second dimension. So we have a situation where we have rows and columns. The rank is 2, because if we want to get to any individual box, we have to specify the row, like 1, and the column, like 3. So if we want the element, we would say position 1, 3. The length of the array is the indexes, 6, times the number of dimensions in the vertical direction, 3, 18. A jagged array still has those indexes in dimensions, but in this case you see that the rows have a different number of elements in each direction. This is not a very common type of array in business programming, but a good example of when I might want to use a jagged array would be hotel rooms. Oftentimes in a hotel, you have a different number of rooms per floor, and the top floor is usually 1 or 2 penthouses. So take note, arrays always start at position 0, and once you create the array, all of the elements will be filled with the default values. So if I have an array of integers, the default of all the elements will be 0. If it was an array of booleans, they would all be set to false. If it was an array of a class type, they'd all be null. If we want to declare a single dimensional array, we need to tell it what type it is, and then put square brackets right after the type. So when we instantiate the array using the new keyword, because it is a reference type just like a class, we're going to tell C# how big it is. So let's look at the code. We have an int array, so int square brackets, that means array of integers. You give it a name like any other variable, equals, and then when we want to instantiate it, we say new int array and how many positions? 5. So this would be a single dimensional array with 5 elements that are all defaulted to 0. If we want to read or write values to an array, we use the square brackets and we give the numerical coordinate of the element that we want to access. So again, let's look at some code. That array we declared in the previous slide. Position 0, we want to set equal to the number 1. Position 1 we set to 4, 2 to 10, 3 to 8, 4 to 7. By the time all these statements run, the array will now look like this. Starting at index 0, we'll have the value of 1. So assigning to an array is just like assigning to any other variable, except we also have to tell it which spot we want to put the value in. We can also loop through an array. This is very common to do with array structures. The for loop is great at this because a for loop we have to specify the starting and ending value of the loop. For an array, we know that we always start at 0 and we always end at the length of the array or the length of the array minus 1, depending on whether you use a less than or equal sign in your for loop. So let's take a look at how we would loop through a single dimensional array. For, we're going to start with I at 0, I less than the length property of the array, add 1 to I each time. And we're just going to print out the value at position, and we're going to give I, which is going to be the index, is, and then we're going to read out the value of the index. So you use the variable name of the array with square brackets. The number or variable that you pass in there is going to grab the value from that position. When this code gets run, it's going to print out those values that we put in the previous slide. Multi-dimensional arrays behave very similarly to single-dimensional arrays. To declare the array, we're going to put the type, we're going to put the square brackets, but we're going to put a comma for each dimension greater than the first one. Then when we instantiate it, we're going to tell C# what size each dimension actually is. So here's a 2-dimensional array. We're going to say int array with a comma inside it. That comma means that there's 2 dimensions, and when we access the array, we're going to do dimension 1 position, comma, dimension 2 position. So this will create a 2 by 3 array, and it's going to look something like that. If we had 2 commas and 3 numbers, we would end up with a cube structure. Assigning values by index in a multi-dimensional array is very similar to using a single-dimensional array. The only difference is now instead of just providing one value, we have to provide a value for each dimension. So in our 2-dimensional array, we need a value separated by a comma, a row, and a column. So here's some code that starts from position 0, 0 and works its way up through each of the columns in the 0 dimension, and then does the same thing in the dimension of 1. 6 values. That's going to put the values in the array looking something like this image right over here. The thing to remember is that when you declare the array, the order of the dimensions specifies the maximum value and the order that you put in for accessing a single element. If we want to iterate a multi-dimensional array, we need to use nested for loops, and we're going to have one for each dimension. So for a 2D array, we're going to need 2 for loops. For a 3D array, we would need 3, etc. The good news is that multi-dimensional arrays in business applications are not very common. They're far more common in gaming applications. But if we wanted to loop through this 2D array, we would start the outer loop, which is the variable I, to go from 0 to 1. The inner loop would go from 0 to 2, and we call that j. And it's very common for developers when they're making for loops to start the outer loop with I and then go up one letter of the alphabet for each internal loop. It helps you keep track of where you are in the depth. So this is going to print out the value at position x comma y is, and it's going to give the value of the element. And you can see when we printed that out, we have our outer variable I, our inner variable j, and then the element of the array at position I comma j. And that's going to print out each of those 6 values from the previous slide. There's 2 properties on every array that I want to make you aware of. They're called the rank and the length properties. They will tell you how large your array is. Rank is the number of dimensions. Length is the total number of elements that are available. We often use length in for loops when we're going through an array.